Hello everyone, today we are going to do the estimation of the septic tank and the soak pit. Here is the section of the septic tank and this is the top view of the septic tank. Similarly, this is the section of the soak pit and this is the top view of the soak pit. The actual 3D view of the septic tank is this. So here is the section of the septic tank and this is the 1:3:6 cement concrete. And here is the slope of 1:20. These are the brickworks in both sides. And this is the baffle wall. And this is the cover, that is the RCC roof slab. And this is the inlet pipe. And this is the outlet pipe. And here is the 3D view of the soak pit. You can see that this is the roof cover slab of the soak pit. This is the brickwork. The outermost part is the 15 cm coarse sand portion and this inner portion is the 15 cm brick aggregate portion. So the section of the soak pit is this. Here we can see that this is the brick aggregate which is laid in this soak pit. This is the brickwork portion. The outermost portion is the 15 cm coarse sand and this portion is the brick aggregate portion here. Now our first step is to calculate the earthwork in excavation for the septic tank. That means we have to do the excavation of the septic tank from this portion up to this portion and up to the height of the ground level. That means we have to do the excavation of the length from this point up to this point. So we have to first calculate the length of this septic tank. Here we can clearly see that the inner dimension of this septic tank is 200 cm. And this small portion is 20 cm and this portion is also 20 cm. And we have already given that this portion of the wall, that means from this wall up to this wall is 40 cm and this point up to this point we have 30 cm dimension. So now we have to calculate the small length and this length is this wall 30 cm minus this wall 20 cm. So this small portion is 30 minus 20, that is 10 cm here. And similarly in this case also, this wall is 30 cm from this point up to this point and this portion is 20. So this length is 10 cm. And similarly now we have to find the length of this point to this point. So we have this total length 40 cm. And this wall is 30 cm. So this small portion is 40 minus 30 equals to 10 cm. So we have this wall also 10 cm and this small portion is also 10 cm. So we get this total length 280 cm. That means we get this 280 from this outer point to this point. So our length of excavation is 280 cm, that is 2.8 meter. So we get the total length 2.8 meter. Now we have to find the breadth of the excavation. To find the width, we have to calculate the total length from this point up to this point. And we have already this inner dimension of this septic tank 90 cm from this point to this point. And this portion of this wall is 20 cm and this is also 20 cm. We have the length of 30 cm from this point up to this point. That means this small portion is 30 cm minus 20 cm wall. That is, this small portion is 10 cm from this side and this side also. And similarly we have this portion 40 cm and this wall is 30 cm. So this small portion is 40 minus 30 equals to 10 from this side. And here also same process. That is, this wall is 40 and this wall is 30. So the small portion is 40 minus 30 equals to 10 cm. So the total width of this septic tank is 10 plus 10 plus 20 plus 90 plus 20 plus 10 plus 10, that is 170 centimeter. That is, the width equals to 1.7 meter. So I can write the breadth equals to 90, that is 0.9 plus 2 into 0.2 meter wall plus 2 into 0.1 projection from both sides and again 2 into 0.1 projection from both sides. So we get the width equals to 1.7, and now we have to calculate the height of excavation. We have to do the excavation from this point up to the ground level. The height of excavation is from this point up to this point, and we have this small portion 20 centimeter. That is, this portion is 20 centimeter height. This is also 20 centimeter, but we can clearly see that there is a slope of 1 in 20. That means we have this height 10 centimeter, and the height is not constant all over this length. So we have to calculate the height at the midpoint. That means we have this inner to inner portion of this septic tank 200 centimeter from our top view. That is this inner to inner portion of the septic tank. That means from this point to this point is 200 centimeter. That means we have this portion 10 centimeter height, and we are going to find the small height at the midpoint. That means this length is 200. At the length of 200 we have the height of 10 centimeter, and at the length of 100 centimeter, that is 200 by 2 at the midpoint. We are going to find this unknown value, and by solving this we get the value of x 5 centimeter. That means the small portion is 5 centimeter, and we are going to find the height of excavation from this point up to this point. So we can easily write this height 20 centimeter plus this small portion 5 centimeter plus this portion 140, and plus the small portion is 30. So we get our height of excavation, that is 195 centimeter. That is, our height equals to 1.95 meter. So I can write the height equals to 0.2 meter this portion of cement concrete plus slope of 5 centimeter, that is 0.05, plus this portion 140 plus 30, that is 1.4 plus 0.3 meter. So we get our total height of 1.95, and the total quantity we get is 9.28, and the unit is cubic meter. Now our next step is to calculate the earthwork in excavation for the soak pit. Now we are going to do the excavation of the soak pit, and here we can clearly see that we have to do the excavation in two parts. That means this upper portion and the lower portion, because we are going to do excavation in the lower portion from this point to this point only, but at the upper portion we have to do the excavation from this point to this point. That means we have different diameter for the excavation. First, let's do the soak pit of the upper portion. That means this portion. We have to do the excavation for the circular trench from this point, the ground level. We know the formula for the area of the circle, that is pi by 4 into d square, and we have to calculate the diameter from this outer to outer portion. So the total diameter of this outer to outer edge is 100 centimeter, inner to inner portion, plus 20 centimeter from both sides, plus 15 centimeter on both sides, and this portion is also 15 centimeter. That is, this is the 15 centimeter brick aggregate. So the total outer to outer dimension is 100 plus 2 into 20 plus 2 into 15 plus 2 into 15. So we get this outer to outer dimension 2 meter. So I can easily write area equals to pi by 4 into 2 square, and we have the number of soak pit 1, and we know that total volume equals to area into height. Here we can see that we have to do the excavation from this point up to the ground level, and we are going to do this as the lower portion. So in the upper portion we have the height of 250 plus 50, that is 300 meter height. So I can easily write the height equals to 2.5 plus 0.5, that is 3 meter, and by calculating this area into height we get our total quantity 9.42, and the unit is cubic meter. Now we are going to find the excavation in the lower portion. That means from this point to this point we have to calculate the total diameter. So our total diameter equals to 100 centimeter plus 20 centimeter wall from this side and 20 centimeter wall from this side. So we get the total diameter of 1.4 meter, and we have the height of the excavation of lower portion, that is 20 centimeter height. So I can write the numbers 1, and we have the area of the circle pi by 4 into d square, in which diameter equals to 1.4, and this height is 0.2. So height equals to 0.2, and we get the total quantity 0.3. Unit is cubic meter. Now we get the total 19 cubic meter. Now our next step is to calculate this cement concrete of 1:3:6 ratio. That means here we can see from the section, that is, we are going to do this cement concrete in this dotted portion. That means we have this as the rectangular portion and this portion is our sloping portion. That means we are going to put this cement concrete all over this septic tank, and in the inner side there is also a sloping portion. There also we put this cement concrete. So we are going to calculate this as floor and foundation. That means this lower portion, that is rectangular portion, and this sloping floor, that is this slope portion. So we have number 1, and the length is this outer to outer length. That means this point to this point we have length of 2.8 that we have already calculated. So length equals to 2.8, and we have already calculated the width. That means from this point up to this point, that is the outer to outer width. So we have already calculated this breadth, so I can easily write 1.7, and we have the height of 20 centimeter, that is 0.2 meter. So we get the total quantity 0.95 cubic meter. Now we are going to do this sloping floor, that is the triangular portion. So we have this total inner to inner length 200 centimeter. So if we find the area of this triangle, that means 1/2 into base into height and multiply by this width, that means this width, then we will get the total volume. So we can simply write 1/2, and base is our 200 centimeter. So I can write 1/2 into base into height, and here we have the base from this point to this point is 200 centimeter, that is this point, and we have the height of 10 centimeter. So I can write the area equals to 1/2 into base, that means this portion to this portion we have the dimension of 2 meter, and we have the height of the small portion, that is 0.1 meter, and we have to multiply this area by its width, and we have the width of this 90 centimeter, that is 0.9 meter, so into 0.9. Or we can also do another method for calculating cement concrete in the sloping floor. For this we have the number 1. We have to calculate this length into breadth of this portion, that means 200 into its width, that is 0.9, and we have to multiply by the height of this mid section. That means we have already calculated the small height at this middle point is 5 centimeter, that is 0.05. So I can write the length equals to 2 meter. So the width is 0.9, and the height of this slope portion at its midpoint is 5 centimeter, that is 0.05 meter. So we get the same, that is 0.09 cubic meter. So you can do by any method among these two. Total quantity is 1.04. Now our next step is to calculate this first class brickwork in the cement mortar for the septic tank. That means this brickwork portion, and here we can clearly see that we have the number of footing 2 in number, that is this is the first footing and this is the second footing. So we are going to do this by long wall short wall method. When we see this portion, that is this 30 centimeter brickwork portion in the top view, then it will look like this. That means these all walls are of 30 centimeter, and we are going to do by long wall short wall method. Here we can clearly see that we have the 2 number of long wall, that means these 2 portions are our long wall and these 2 portions are our short wall. Here also we have these 2 short wall. So we have this outer to outer length, that is 200 plus this wall 30 and this wall 30. So the total length is 260 centimeter, that is 2.6 meter. And so here we have the long walls 2 in number, so number equals to 2, and the length equals to this inner to inner portion 200 plus this wall is of 30 centimeter and this wall is of 30 centimeter. So I can easily write 2 plus 2 into 0.3 meter wall, that is 2.6 meter. So length is 2.6 and we have the width of the wall 0.3, that is these all portion are of 0.3 meter, that is 30 centimeter. And we have the height of the first class brickwork up to this portion, that is 60 centimeter. So the height is 0.6. So the total quantity is 0.94. Now we are moving to this second footing, that means these 2 portions of 20 centimeter width. So we have obviously a number of long walls 2 in number, that means we have this second footing and we have this long wall 2 in number, that means this portion and this portion, and we have the length of this inner portion is 200 centimeter, that is 2 meter, and this wall of 20 and this wall is also of 20, that means the outer to outer length of this long wall is 240. So I can easily write the length equals to 2 meter wall plus 2 times of 0.2 meter width of the wall, that is 2.4 meter. So the length equals to 2.4, and we have this width of the wall 0.2 meter, that means this portion is 0.2. And now we have to calculate this height, that means from this point to this point. So we have already calculated this total height of this septic tank at this center is 195. That means you can see in the first step, that means height of excavation. To calculate this height, we have to subtract this 20 centimeter and this 60 centimeter. So 195 minus 20 centimeter minus 60 centimeter is 115, that is 1.15 meter. So we can easily write this second footing height equals to 1.15 meter. So we get the total height of 1.15 and the total quantity is 1.1 cubic meter. Now we are going to find this short wall. That means here we have already calculated this long wall from these two portions, and now we can clearly see the short wall is this portion and this portion. So we have this length of the short wall is 90 centimeter, that is 0.9 meter. So we can write the number of the short wall 2 having the length of 0.9, and we have this width same, that is 0.3, and we have this height same, that is 0.6. And similarly we have this second footing also 2 in number, and we have already considered these two as the long wall, and the remaining is these two short wall, that means this portion and this portion. That means the length of this short wall is 90 centimeter. That means here also we have this point to this point 90 centimeter. So we can easily write the length equals to 0.9 and the width is same, that is 0.2 meter, and height is also same as the second footing, that is 1.15. And here we get the total quantity 0.32, and here we get the quantity 0.41. So while adding all this, we get the total quantity 2.77. Now we are going to calculate this second class brickwork in the soak pit, and here we can clearly see that this portion is our dry brickwork and this portion is brickwork with 1:6 cement mortar. And one thing you have to remember is while calculating this brickwork, that means this is our hollow portion. So while calculating this hollow portion, we have to find the CSA, that is the perimeter into length. And while calculating the perimeter, we have to use the formula pi into d. Diameter is the center to center diameter. So firstly we have to calculate this upper portion, that means these portions. And here we can clearly see that this is a circular portion and this is hollow inside. So upper portion number 1, and we have this wall 20 centimeter, this is 100 and this is 20. But while calculating this diameter to find the CSA, we have to find the center to center length. That means from this point up to this point. That is total diameter equals to 100 centimeter plus 20 by 2 from this side and 20 by 2 from this side. That means if you multiply this center line by its breadth, that is 20 centimeter, then we will get the total CSA of this circle. So I have to write the diameter equals to 120, and we have the perimeter of the circle pi into d, and pi d is our length, and if you multiply by this width, that is this width is 0.2 meter, that is this portion 20 centimeter. So width equals to 0.2, and we have to multiply by its height. And now we have to calculate this height of this upper portion. That means this is the brickwork in the upper portion, so the height is 50 centimeter, that is 0.5 meter. And we are also going to do this brickwork in this lower portion, and we have this diameter same, that is 100 plus 0.2 by 2, and here also 0.2 by 2, that is diameter equals to 1.2 meter same, but height equals to 20 centimeter. So I can write the numbers equals to 1. Perimeter is same, that is pi into 1.2, and the width is also same, that is this width is also 0.2. So width equals to 0.2 and the height is 0.2. And here the total quantity is 0.58. Now we have done this brickwork in this upper portion and this lower portion, and this middle portion is remaining, and we have this middle portion as this dry brickwork, so we are doing this in the separate topic. So we are going to do this middle portion, that means from this point up to this point, and we have the numbers 1. Our perimeter is same, that means pi into d is same as above. And we have this width 0.2 meter same, that means this portion is also 0.2, and the height is 2.5 meter, that means this point to this point is 2.5 meter. So height equals to 2.5. Now we are going to do this RCC work for this soak pit and the septic tank, and we have this RCC work in this upper portion, that means this roof cover. That means this roof cover is our RCC portion. Here we can clearly see this is 7.5 centimeter RCC slab. Similarly, In this septic tank also there is the roof cover slab, that is 7.5 cm RCC slab precast, and another RCC work is here, that is 4 cm RCC baffle. That means we have only 3 RCC work. So first let's do this roof cover slab of septic tank. So the number is 1. So this is the roof cover of the septic tank, and we have to find this total area of this septic tank and we have to multiply by this height. We have the roof slab from this point up to this point. So the total length from this side up to this side is 200, that is inner dimension of the septic tank, plus 20 cm wall plus 20 cm wall, that is 240. So I can write the length equals to 2 meter inner dimension plus 2 times of 0.2 wall, that is 2.4. Roof cover is placed in this way. That means we have to find the width from this point up to this point, that is this length is 90 plus 20 plus 20, that is 1.3 meter. Here also we can visualize this is 1.3 meter. So width equals to 0.9 plus 2 into 0.2 meter wall, that is 1.3 meter. And the height of this RCC slab portion is 7.5 centimeter, that is 0.075. So the total quantity is 0.234. Now our next step is to calculate the roof cover slab of the soak pit. That means we have to place this cover in this whole circular portion. So we have to first find the area of the circle, that means pi d square by 4, and multiply by this height. So we have this RCC slab in this portion, that is from this point up to this point. So the total diameter equals to 100 plus 20 plus 20. And one thing you have to remember is while calculating the area, we have to find the total surface area. That means we don't need to find the diameter of center to center diameter. We can find the diameter from outer to outer point. Just remember that while calculating the perimeter, you have to find the diameter, which is the center to center diameter. And while calculating the area, that means while calculating pi d square by 4, you have to find the outer to outer dimension. So the outer diameter equals to 140, that is 1.4 meter. So I can write the diameter as 1 plus 2 into 0.2 meter wall, that is 1.4. The height of this RCC slab is 7.5 centimeter. So I have to write 0.075 meter. So the height is 0.075 and we get the total quantity 0.115 cubic meter. Now our next step is to calculate the RCC work in this baffle wall. That means we have this baffle wall of 4 cm thickness, and while calculating this length, there is a bearing of 5 cm on this side and on this side. So the total length of this baffle wall is 90 cm, that means this portion, plus 5 cm plus 5 cm, that is 100 cm. So the total length of this baffle wall is 0.9 meter plus bearing on both sides, that is plus 2 into 0.05. So the total length is 1 meter. So we have this number of this baffle wall 1 in number, and the length is also 1. So we have this width of this baffle wall 4 cm. That means this portion to this portion is 0.04 meter. So we can write the width equals to 0.04. The height of this baffle wall is from this point to this point, that is 30 cm plus 15 cm. That is this point to this point is 0.45 meter. Here also 45 centimeter. So we can write the height equals to 0.45. So here we get the total quantity 0.367. Now our next step is to calculate this cement plaster in the septic tank. That means we are going to do the plaster in all these inner surface and this floor also. And for calculating this floor, we will calculate this in the separate topic, and here we are going to calculate only on this sides wall. So while doing this plaster, we have to find the length and multiply by its height. Then we will get this portion. Length multiply by its height, we will get this portion. So we have the total length of this septic tank 200 meter, and the height of this plastering is 140 plus 30, because this portion is already cement concrete. So we have to do the plastering from this point up to this point. So we have the long walls, that means these two portions are considered as the long wall. That means this point to this point, and here also this point to this point. That means 2 number of the long wall having the length of the 200. So the long wall is number 2, length equals to 2, and we don't consider the width, we have to consider the height. That is, the height equals to 140 plus 30, 1.4 plus 0.3, that is 1.7. And we get the total quantity 6.8. Similarly, while calculating this short wall, That means now we are going to do the plastering on these walls. So we have this total length 90 centimeter. So the length equals to 0.9, and we have two number of short walls, and we have the height of this point to this point, that is 1.7 meter, and we get the total quantity 3.06. Now we are going to do this cement plaster in this floor. That means we can simply multiply this 200 into 90. That means this floor portion. So the number equals to 1, and the length is 2, width is 0.9, so we don't consider its height, and the total quantity is 1.8 meters square. Now our next step is to calculate this 50 mm size brick aggregate in the soak pit. So we are going to do this portion as the outer side of the soak pit, and this portion as the bottom of the soak pit. So we have this outer portion of the soak pit 1 in number, and we have to find the CSA, that is pi into d into length. So first let's find the diameter of this portion, that is inner portion is 100 centimeter, that is 1 meter, plus these two wall are of 0.2, so 2 into 0.2, plus while calculating the center to center portion we have to find 15, this is 15 centimeter, but we have to write 0.15 by 2, and again here also this is 15 centimeter, and we need to calculate 0.15 by 2 to find the center to center diameter. So we get the total 1.55. So the length equals to pi d, that is pi into diameter is 1.55, and so the width is 0.15, that is this portion is 0.15. So the height is this point to this point, that is 2.5 meter. So the total quantity we obtain is 1.83, but here at the bottom we can clearly see that this is not the hollow portion. That means here we can see that this is a solid portion. So here is a solid portion all over this soak pit. So while calculating the solid area we have the formula pi d square by 4, but these are the hollow portions, so we have used the formula perimeter into length. So we have the numbers 1, and we have the formula pi d square by 4 where diameter equals to outer length. That is this brickwork portion is from this point to this point, that is this inner portion is 100 centimeter. So the diameter equals to 100 centimeter, that is 1 meter. So we can write pi by 4 into 1 square, and we have this height of this brickwork, that is 20 centimeters, so height equals to 0.2, and the total quantity is 0.16. And now we are going to find this coarse sand portion, that is this is the coarse sand of 15 centimeters. So this is also the hollow portion, so we can write the numbers equals to 1, and firstly we need to find the diameter, that is the center to center diameter. We have to find the diameter from this point up to this point. This is 15 by 2, this is 15 centimeter, this is 20 centimeter, this is 100 centimeter, this is 20 centimeter, this is also 15 centimeter, and this is 15 by 2. So we have to calculate the total diameter from this point to this point, and we obtain 185 from this point up to this point. So diameter equals to this inner portion is 1 meter plus 2 times into 0.2, that means these walls are of 20 centimeter, and this aggregate is also 15 centimeter, 2 into 0.15, and plus while finding the center to center we have to do 2 into 0.15 by 2. So we get diameter of 1.85. So this is also the hollow portion, so we have to write pi into d, so pi into 1.85, and the width is this coarse sand is of 15 centimeter, so 0.15 centimeter coarse sand, and it is up to the height of 250, that is 2.5. So the total quantity is 2.18 cubic meter. And lastly we have to find the iron footsteps, 1 2 3 4 iron steps. So simply we have 4 number, so we have 4 nodes, 4 number. In this way we have completed the estimation of the septic tank and soak pit for 25 users.